So, looking at this problem now with the experience that you're developing with and through me, what do you notice about the problem that tells you how you should start it? What's in the problem that tells you how you should probably start this? What operation, if you will? Say again? Multiplication. All I see for days is multiplication. So because of that, I'm going to see possibly use substitution as my first go-to. Okay? So when I look at this, I would do something like the following just to get my brain going as far as organizing stuff. The only thing that I've created now is a parenthetic piece that was understood, that wasn't written before. And the reason why I do that is because with use substitution, I'm trying to find the biggest parentheses pieces that I can find. You with me? All right. What else from what we have right now do you think I would look at that is kind of red flagging me right now? The constant multiple rule. Nice. I would look at this and see this 4, not this one, because that's not a constant the way the first 4 is, that I can pull out and rewrite it as 1 over theta squared cosine of 4 over theta. And the thing is for you, you're going to be asking, how did you know to do that? It's through practice and experience. Okay? If not, I'm trying to give you my go-tos. All right. From here, what do you think the next step could be? Use substitution. I'm going to do use substitution. Here we go. U equals, and I'm looking for the biggest parenthetic piece that I can find. What is it? 4 over theta. 4 over theta is the biggest parenthetic piece that I can find as of right now. We good? Now, let's...
Why wouldn't we include the cosine?
The reason, this is a good question. Why would you not include the cosine? Because look, if I ask you to take the derivative of this, what rule are you thinking of? Chain rule. See, right now, I see a lot of confused faces because you're used to integrating, walking backwards, if you will. And now what I'm asking you to do throughout an integration is to walk forward a little bit. Deriving, which we haven't done for a while. Okay? So, I'm making you dance. All right, so if I look over here and I take the derivative of this, what rule comes to your head whenever you look at that? Chain rule. So it would be the negative sign of the stuff times the derivative of the stuff. You don't see a negative sign anywhere there. So you've created something that was not even in the original problem that we can't pick up. You with me? That's why we don't want to go for that big parenthetic piece. Look, this is too big if I go for that for my use substitution. Let's go to the 4 over theta. With experience, you'll develop where is the better parenthetic piece. Okay? So, 4 theta to the negative 1 is how I would write this. You with me? Because 4 is a constant and theta is a variable. What's the derivative that you see? What does this become if I derive it? Negative 4 theta to the negative 2. Remember, you're walking forward. Some people will add 1, get 0, and divide by 0, and it's undefined. Understand which way you're dancing or walking as you're deriving for the piece or you're integrating for the final answer.
Negative 2 then?
Sure, negative 2 is correct.
No, I mean like the number in front, because you pull the negative 2 down.
Oh, no, I pulled this. So all I did was derive. So now this is negative 4 over theta squared. Are you with me? Okay, so I'm going to put du is equal to negative 4 over theta squared. Oh, d theta, right? D theta, because we have to do it implicitly. All right, let's look for the pieces that were in our original problem that we rewrote. So far, I've accounted for u is going to be right there. And du, everywhere where du is at, I'm looking for these pieces, per se. Alright, let me do this in orange. I see d theta and I see theta squared. In the original, I see that. You with me? Because I'm going where all my variables are at. But then this -4 kind of gets people sometimes. You with me? So the way I like to show it is I will divide by a -4 on both sides so that I get something that looks like this. Notice that this is still what is being replaced, basically, that I'm looking at in my original problem. Okay? So now, where this used to be in this original problem, I'm now going to replace it with -1/4 du. Okay? I'm going to substitute it with this. Okay? Here we go. Watch the progression. I'm going to start with the cosine of u. Are we good? Okay, so I've accounted for this piece. I'm going to gray it out as I go through. I've accounted for this piece right here. Now I'm about to account for d theta over theta squared. Where I see d theta over theta squared, I'm going to replace it with a -1/4 du. So now for my original, this just got replaced. The one's understood. I don't need that. But what's one thing that's glaring at me that I haven't yet accounted for? Is the 4. Well, the 4 is going to be constant multiple ruled in. And be careful, because this is multiplication, not subtraction. So that ultimately that 4 and the -1/4 will cancel to what? -1. Okay? So you're going to write your thing. Let me go ahead and rewrite this. My final is going to be a negative cosine of u du. It's almost like you encrypted, to me, let's say that this is, I don't know, some war or whatever. We are trying to encrypt this message through u substitution to be something a lot simpler. It's like decoding something, if you will, but in a different variable. Okay? And we do this with these multiplicative pieces. What's the antiderivative of cosine? Sine, right? So sine is the antiderivative, sine of u plus c. But don't forget, constant multiple rule, you're going to attach this negative. That's where all these negative mistakes occur. This is almost my answer. The only difference is that this is written in terms of u, and we want it written in terms of theta. So I'm going to grab this theta piece that I originally signed as u, plug it in, and I'm done. The steps can be long sometimes, but I promise you, for the most part, they're pretty much the same all the time. Your approach. Are we good? Dreads, I could give you dreads, and you could follow that all day, and you'd always get the answer. But here, I can't give you an acronym because some people rewrite or manipulate differently than others. Okay?